What's up everyone, Laconde Mwila here, back with another video, and we're talking K8s. Last time around I dealt with the topic of mutual authentication and encryption between services using mTLS in Istio. Now I want to talk about the second leg of securing communication between your services, and that's authorization. Authentication is about validating who you are, whereas authorization is about confirming what you're allowed to do. In short, access control. Let's take the example of a corporate setting. Usually, companies will hand out something like an identity badge or a card that confirms who you are to the company, whether you're an employee or a visitor. In addition to this, depending on your role or function, you'll be given a certain level of access to the company building and its resources. This is a good approach to managing security risks, and we can apply the same principles to our services using Istio. After we've validated the identity of a service, we should check whether or not it's permitted to carry out the desired action when communicating with other services. These actions are basically the different CRUD-based operations. This is create, read, update, and delete. So just because services coexist in the same service mesh and have a verifiable identity, it doesn't mean they should be trusted with carte blanche access to every single service in the mesh. So how exactly does Istio implement this? With the authorization policy resource, you can define access control rules at different levels or scopes. It could be the entire mesh, a specific namespace, or a specific workload depending on your use case. The envoy sidecar proxy is what's actually responsible for executing this. So when the service proxy intercepts incoming requests, it will use the authorization policy to verify if the sender has the right permissions to carry out the specific action. Using the policy, the proxy will either allow or deny the request. So when I create an authorization policy, IstioD is going to process it and update the Istio data plane accordingly. When you're working with authorization policies, there are three fields that you're going to be working with: selector, rules, and an action. The selector field, as you'd expect, is used to specify the workloads that the policy should be applied to. The rules field is where we define the rules that should activate the policy that we're creating. And lastly, the action field is where we specify what action should be taken once one of the rules in the policy matches the request, whether it should be allowed or denied. Now, the rules can get a little bit complex depending on how you want to define them. You can essentially create rules with properties from, to, and when. In my case, I'm only going to work with from and to. The from field can be a principal, namespace, or an IP block, and it specifies where the request is coming from. In short, it's source. The to field is where you detail the operations of the request, like the host or the method. And the method would be your typical CRUD-based operations like get, post, put, or delete that you would run when working with an API of some sort. And the when field specifies conditions that have to be met after the rule has matched the request. Now let's turn our attention to the application that I'm actually going to be working with, or applications rather. I've got two separate workloads running in the mesh. I have my express test application and an e-commerce app which consists of orders, products, and GraphQL. Now let me switch back to my authorization policies. Now my policies are going to use the namespace as a source. You can see that over here. And the namespace is fetched from the SPIFFE Verifiable Identification Document, or SVID for short. So that means mTLS has to be enabled in order for this to work. If you watched my previous video, you'll recall that I mentioned mTLS is enabled in Istio by default, but it's set to passive mode. I've set it to strict mode so that the data plane enforces authentication between any communicating peers in the mesh. And this is my peer authentication custom resource definition, which I've already applied. So this means that it is set to strict mode and any communicating peers in the mesh have to have a verifiable identification. All right. So now I haven't applied any authorization policies at this point. So that means my express test application can successfully make requests to apps in the e-commerce namespace, like orders and products, because of the mutual authentication. Now let's test this out. All right, so you could see that I was able to successfully make requests both to the orders and the products APIs running in the e-commerce namespace. But we might decide that just because we know the identity of express test, that doesn't mean it should be allowed to make these requests, especially to orders, because it's likely to contain some sensitive information about who placed the order. So I'm going to implement an authorization policy attached to the e-commerce workload that only allows traffic from the e-commerce namespace, and that's this authorization policy over here. And it only allows GET requests to version 1 of any app, as you can see. And by allowing one or more allow rules, all traffic will be denied unless it's explicitly matched an allow rule. So as you can see, I'll just quickly go over that again. My selector specifies that this is for the e-commerce workload, and under my rules, this is for the source. The source is the e-commerce namespace, and this is for any operations, any GET operations to any version 1 of applications running inside of this namespace, and it is an allow rule. And like I said, by implementing this, if you have just one or more allow rules, all other traffic will be denied unless it explicitly matches an allow rule. So I'm going to apply this to my cluster now, and IstioD is going to process it and propagate it to the entire data plane. And then we're going to see what the effect of this is by going into the express test container once again and seeing if it can make any requests to orders and products. All right, so you can see I have successfully created that, and I am still inside of my express test container over here. I'm just going to quickly exit so that you see that for sure. And shell right back into it. And because I run those commands recently, I'm just going to quickly scroll up here to try running them again. I'll start with orders. Okay, and it worked. So I'm hoping that it just hadn't yet propagated. So I'm going to delete orders, and I'm going to try running that request again. And there we go. So you see, now I'm getting a forbidden error. So this is correct. So the reason it worked a few seconds ago is just because it hadn't yet propagated completely to the data plane. So this is the result that we expect to see. And if I try the exact same thing with product, once again, I get a 403 error. So that means that our authorization policy is in place. And what I'm going to do now is I'm going to shell into the products container and attempt to reach the orders container, because that should successfully work. Because remember the allow rule, we actually created an allow rule for any traffic coming from inside of the e-commerce namespace. And this was a deny that happened implicitly because of that allow rule. All right, so I'm in the products container. Now, because products and orders are in the same namespace, I don't have to specify the namespace over here. I can just specify the name of the service, which is orders service. And you can see that the request executed successfully. If I run a cat command here on orders, you can see I was able to get all the order information. So our authorization policy is working as expected. And I'm just going to delete that. All right. Now, you might also decide that it's actually safe for express test to query the products API because that information is publicly visible on a website, right? Orders, on the other hand, is likely to contain some sensitive information. Now, you might have seen when I run that cat command, there were details like who created the order. And generally speaking, you wouldn't be able to fetch the details of an order of someone of another person. So we expect that to be concealed from us, but products information is something that might be made available to some applications inside of the mesh. So what I'm going to do now is create an authorization policy for the e-commerce workload that allows traffic from the default namespace where express test is, but only to perform GET operations on the products API. So you can see over here, once again, this is for the e-commerce workload. and it is for any traffic coming from the default namespace. That's the source that I've set. And this is for specifically for get operations on the products API, and it is an allow rule. So the result that we should see is that Express test should be able to successfully query, send a get request to the products API, but should still fail to make any requests to the orders API. I'm going to quickly come back to my terminal. I'm going to create that. And I'm going to shell back into the Express test container. And now I'm going to try to send a request to the products API. So still getting it forbidden. So I'm going to give it a couple of seconds and hopefully just wait for things to propagate and that it will work successfully. And there we have it. So I'm able to make requests to products API. Once again, I'm going to run the cat command on products. You can see I have that information available. But we want to make sure that we're not able to make any requests to orders. So I'm going to attempt to do that. And you see I'm still getting a 403 forbidden error, which is correct. So our authorization policy is working as expected. Now, if I was to head back to products, just to make sure that my policies have not impacted the communication, the authorization communication within the e-commerce namespace, I'm just going to quickly run another orders command, another request to the orders API from the products container. And I'm going to make sure that I don't have orders existing here. It doesn't look like I do. So I will then run the same command that I run earlier. And I'm still able to send requests to orders. And there you have it. We have strict mTLS in place for the mesh and another layer of security with the authorization policies. Thanks a lot for watching. I hope you found that useful. If so, hit the like button, subscribe to the channel, and stay tuned for more.